Hello, my dear students. Let's talk about ionic equilibrium. Ionic equilibrium is very important topic, and in this topic we are just going to discuss two important terms. The one is acid, the other one is the base. The entire topic is concentrated only on acids and the bases. As you know that there are various theories are there to explain the atomic structure. Like that, initially we got many theories to explain the acidic nature and basic nature of the substances. In that, one of the first theory was proposed by Arrhenius. So that theory is called as Arrhenius concept. You can shortly call it as Arrhenius concept, or you can use the term Arrhenius concept of acids and bases. Very simple, very beginning part of the you can say that explanation part is there for the acids and the bases. What Arrhenius believed and what he thought about the acids and the bases, that we're going to learn. He took an acid, the term acid. According to him, the acid is a substance that gives H plus ions. Okay, this statement is not completed. Acid gives H plus ions, but the condition is the H plus ion should be present in aqueous medium. So therefore the acid gives H plus ions in aqueous medium. This is a drawback for this theory. Later we're going to study that. Now take an example of HCl is a molecule. Take that HCl is a liquid, and now add into the water. I will write as an aqueous medium. Now H and Cl dissociate in the water, and they exist in the form of H plus ions, that is dissociated in the water medium. So therefore we're going to write aqueous plus Cl minus, that is present again in a aqueous medium. Now you can see that we wrote here single headed arrow, means direction of the arrow is only one direction here. Means it is complete dissociation is taking place. Complete ionization is taking place. The molecules which give H plus ions, okay, the molecules or substance which gives H plus ion and it is complete dissociation, then they are called as strong acids. Strong acids. Okay, now you may get a question. What are the strong acid according to Arrhenius concept? Strong acid is a one which dissociates completely in aqueous medium. That is known here as a strong acid. If there is an acid called as strong, it must contain a weak acid also. Then what is weak acid? Take an example of acetic acid. CH3 COOH. This is acetic acid and it is liquid. Now you have to add this in an aqueous medium. And what you get? You get a very interesting thing that I don't want to write here. Okay, I will write single head arrow. Right, single head is there. It is not double headed. And direction is half here. Direction is in this direction towards the product side. Now it forming here CH3 COO minus, and one thing you remember, this is in the aqueous medium. Okay, and therefore this acetate ion, the CH3 COO minus, is called as aqueous acetate ion, and that is present in aqueous medium. And along with that it gives H plus ion, that is also exist in the form of aqueous medium. Now the thing is that this reaction is reversible reaction. Now why is it reversible reaction? Because the CH3 COO minus combined with H plus ion, giving back to acetic acid once again, the backward reaction. So therefore in this case the dissociation is partial. Therefore going to write here partial ionization or partially ionized. Partial ionization. Or in sophisticated words you can use here partial dissociation. If there is partial dissociation is there, then such molecules are called as weak acids. They are called as weak acids. Okay. Now this is all about the acids. And what Arrhenius think about the bases? Let's see. Bases or the base. What is a base? According to the Arrhenius, base is a substance that gives OH minus ions. Is not completed. The substance which gives OH minus ions in aqueous medium. Again, the same drawback term we are using here. Aqueous medium. Take an example of sodium hydroxide NaOH, which is a strong base and it is solid. And when you put this sodium hydroxide in an aqueous medium, it dissociates into Na plus aqueous and then plus OH minus aqueous. Now this sodium hydroxide become a base because it is giving OH minus in aqueous medium. Now you can see that it is complete dissociation is there. We'll write complete dissociation, complete ionization. So then this base is strong. It is strong base. Now take another example of ammonium hydroxide, that is NH4OH. Now this NH4OH is a liquid. Now it dissociates partially and convert into NH4 plus aqueous plus OH minus aqueous. Now this NH4 plus and OH minus react once again and giving back to the product, that is ammonium hydroxide. Now this is a partial dissociation is taking place here. Partial ionization or dissociation. Therefore, the quantity of the OH minus in a reaction mixture is less. So therefore, now this base is termed here as a weak base. Hope you understood that what is strong acid, strong base, weak acid and weak base. Now this is all about the acid base concept of Arrhenius. Now we got a definition, but along with the definition we need something else. We need to understand one of the important terminology known as neutralization. Neutralization, very important term. This definition should be there when we are explaining acids and bases concept. Now thing is that what is neutralization? The term neutral indicate that nothing, right? Neutral, having nothing in the reaction mixture. Now if I take a container and which is containing acid and I have another container which containing the base. When equal moles of the acids and bases are added, the resulting solution is called as neutralization. Now, how to understand this neutralization? Let me take an example. If you put a litmus paper in this, the litmus paper become red. If you put a litmus paper in a base, the litmus paper become blue. But when acid and bases are combined and you get certain solution, okay, and in that solution if you put the litmus paper, there is no change in color, no change in color. Okay, it do not affects the color. Now that is known as neutralization. Okay, so one of the important property of the acid and the base is the reaction with each other. For example, if a solution of hydrochloric acid, that is HCl, and the sodium hydroxide, that is a base, are mixed to in a 1:1 ratio by moles, the resulting solution has no effect on the litmus paper, right? Because the following reaction is taking place there. Let's write that following reaction. The following reaction is HCl, that is present in the aqueous medium, and that is reacting with the sodium hydroxide NaOH, and that is also present in the aqueous medium. They react with each other and forming a salt, that is NaCl, and that is again present in the form of aqueous medium. Now along with that we get H2O, Now this is the reaction. The acidic and basic property of the solute disappears because we got new products here. So that is salt and water we get. Okay. We say that an acid, the base neutralization has occurred. According to the Arrhenius, acid and a base neutralization is simply the combination of H plus ion, which is present in aqueous medium, and OH minus ion, which is present in a aqueous medium, to result a molecule of H2O. This is the definition for the neutralizations provided by the Arrhenius. Now let's see the limitation of this theory. We'll write the heading limitations. So very beautiful topic is there. So we'll learn many things in this. So limitations are very important to overcome this theory or these limitations the new theories give. The first limitations we can list here, that this theory particularly fails the behavior of acid and bases in non-aqueous solutions. It fails to explain behavior of acid and base in non-aqueous medium. Obvious, students, because medium, obvious, this theory is strictly depends on the H substances which giving H plus ion and OH minus ions in aqueous medium. But there is absence of aqueous medium is there, then how these acids are behaving? That behavior is not explained by this theory. The second limitation of this theory is that it fails to explain the neutralization in the absence of solvent. Like if there is calcium oxide is there, that is a solid, and carbon dioxide is a gas, when these two combine and form here calcium carbonate, it is a neutralization process, and this is solid and this is a gas and forming here solid. This reaction occurs even in the absence of solvent. So why or how this reaction is occurring, or you can say that one more thing, that calcium oxide is behaving here as a base and carbon dioxide is behaving here as an acid. Now these acid base reactions are taking place in a air or some other medium. Now there is no solvent is there, even though such kind of reaction is taking place, and process is called as neutralization. Neutralization is taking place. Right, this theory do not explains this, means neutralization in absence of the solvent. Now the third drawback of this theory is very interesting. For example, if you take AlCl3, boron trifluoride, and even we can take some examples like NH3 for the bases, NH3, or you can take here PH3. So AlCl3 and boron trifluoride are acids, even though they don't contain the H plus ion. NH3 and PH3 behave as a basis. Even these two molecules or such molecules do not contain the OH minus ions. So therefore, this theory fails to explain the acidic character of AlCl3 and basic character of NH3. Now fourth one, this theory could not explain how H plus ion exist in aqueous medium. This is not explained, students. Now this is all about the Arrhenius theory. What you have to concentrate, that definition and neutralization definition, and then the sum of the drawbacks. At least you remember the 4 drawbacks of this theory. It will be very helpful, students.